In this video, we consider the graphs of exponential functions. Let's begin by reviewing the formal definition of exponential functions. For positive a not equal to 1, the exponential function with base a is given by f of x equal a to the x. We might need to elaborate on the two restrictions that a is positive and not equal to 1. First, consider what might happen for negative a. Let a equal -2 and suppose that x is a half. Then f of a half would be -2 to the 1/2 power, or the square root of -2, which is not a real number. Thus we require a be positive. Now consider what will happen if a equals 1. Then the function f of x equal 1 to the x is equal to the constant 1, which is not an exponential function. Thus, we also require that a be not equal to 1. Let's first consider the graph of an exponential function with base greater than 1. For example, let's graph the function f of x equal 2 to the x. We will start with axes and a coordinate grid and plot some points. When x equals 0, y equal 2 to the 0, which is 1, so the point 0, 1 is on the graph. Similarly, the point 1, 2 is on the graph, as are the points 2, 4 and 3, 8. We plot some points with negative values of x as well. We have the point -1, a half, and the point -2, a fourth. If that isn't enough points to sketch the graph, we can add in points like √3, 2 to the √3 by approximating 2 to the √3 with approximately 3.321997 as in the previous video. At any rate, we can connect the dots to sketch the graph of the exponential function with base 2. In general, the shape of f of x equal a to the x with a greater than 1 has this basic shape. We just plotted y equal 2 to the x. The graph of y equal 3 to the x is similar, except steeper for positive x values and flatter for negative values of x. Similarly, the graph of y equal 10 to the x is even steeper for positive x values and still flatter for negative x values. If we graph y equal 1.4 to the x power, we see that the graph is flatter for positive x values and slightly steeper for the negative x values. In all of these graphs, we have the point 0, 1 on the graph, the point 1, a on the graph, and the point -1, 1 over a. Let's see what happens to the graph of the exponential function when the base is a number between 0 and 1. We will graph the function f of x equal 1/2 to the x by plotting some points. As usual, we start with a set of coordinate axes and a coordinate grid. We have the point 0, 1, the point 1, a half, and the point 2, a fourth. If we plot some points with negative x values, we get -1, 2, -2, 4, and -3, 8. We then get a smooth sketch of the graph of y equal 1/2 to the x power. In general, the shape of f of x equal a to the x with a fraction between 0 and 1 has this same basic shape. We just plotted y equal 1/2 to the x. The graph of 1/3 to the x is similar, except steeper for negative x values and flatter for positive values of x. Similarly, the graph of y equals 1/10 to the x is steeper for negative x values and flatter for positive values of x. If we graph y equal 1 over 1.4 to the x power, we see that the graph is flatter for negative x values and a little steeper for positive x values. In all of these graphs, we have the points 0, 1, 1a, and negative 1, 1 over a on the graph. Let's summarize the properties of the graphs of the exponential functions. The 3 points, 0, 1, 1a, and negative 1, 1 over a, are always on the graph. If a is greater than 1, then the function is increasing. If a is a fraction between 0 and 1, then the function is decreasing. In either case, the exponential function is a one-to-one function. The domain is the set of all real numbers, and the range is the set of positive real numbers. And finally, the line y equals 0, or the x-axis, is a horizontal asymptote of the graph. An asymptote is a line that the graph gets arbitrarily close to.